Welcome to this episode on genetic modification. And the end goal, really, the end game, is to make recombinant DNA. And it occurs courtesy of two enzymes. The first enzyme is what I regard as a scissor, something that cuts up genetic information, in this case, a gene of interest. And this scissor is equivalent to something called a restriction enzyme. And a restriction enzyme simply cuts DNA, okay, and cuts the gene from, of course, a human DNA structure. So the gene we're going for is insulin. Insulin is, of course, the hormone responsible for reducing blood glucose levels. Okay? And at the same time, we need to use the same restriction enzyme to cut out a part of the plasmid to allow for space for that gene to be inserted in. Okay? So it also cuts plasmid DNA. Just one moment. And secondly, to allow for this gene to be inserted in the plasmid, we use a second enzyme, and it's called ligase. The ligase enzyme, and that inserts DNA into plasmid, therefore making recombinant DNA. And this plasmid acts as a vector, just like a mosquito would, but of course a mosquito carries parasitic infections such as malaria. So vector, the plasmid is a vector in essence. Okay, so going back to ligase enzyme, because I can't draw a glue stick, I'm just going to go for the shortcut Control V, of course, paste. So this is the cut and paste scenario here. Restriction enzymes being the cut, and pasting would be ligase enzyme. And here you have it, you made a recombinant DNA plasmid vector here, and then you would insert that into an empty bacterial cell. You know it's bacterial cell with my attempt of drawing a flagellum there, but yeah. So that's in an empty bacterial cell. And that's going to divide, multiply, and you're going to effectively amplify how much insulin is going to be produced, and you can use that insulin, that gene of interest, to be sort of stored for other purposes, other human applications. Of course, with insulin you can use them in injections to mitigate diabetes symptoms and so on and so forth, and help it as a form of treatment. So that's it really, and crucially you need to know it starts at an early stage of development. Okay, and that should conclude genetic modification. Two enzymes, one plasmid vector, one bacterial cell, multiplication, and that's it. Thank you for listening.